Okay, we are going to investigate in 7.4 the factored form of a quadratic function. If you look in red here at the middle of the screen, you'll notice that in the previous three sections, in 7.1 to 7.3, we investigated what we called the standard form of a quadratic function, which is y is equal to ax squared plus bx plus c. If you wanted to look at these specific characteristics related to that standard form, you may want to look at those lessons. Now what we're going to look at in green here is what is the factored form of a quadratic function. Well, the factored form looks different than standard form of a quadratic function is this: y is equal to a times x plus r times x plus s. In other words, this is a really basic view of this. Not 100% true, but generally what we're going to notice here is for factored form that there are brackets. So for example, if you'd like some examples of factored form quadratic functions, one might be y is equal to x minus 1 times x plus 3, or it could be y is equal to 2 times x plus 4 times x minus 3. Those are all factored form quadratic functions. If you look on the next part of your page, it says if you're in my class to try the following thing on your own. I will give you some guidance on it, but if you'd like to try it on your own, go right ahead. So it says do the following questions and get myself to initial them for correctness. Using a graphing calculator, graph each of the following functions in factored form. Determine the x-intercepts, the y-intercept, and the direction of opening for each. So I've got a graphing calculator here. So what I'm going to do is graph each of these functions that I'm highlighting in yellow and investigate what are the x-intercepts, the y-intercept, and how does it open. And we're going to make some notice some patterns and make some conclusions. So you'll notice here that I'm going to graph the first one, which is y is equal to x minus 4 times x plus 1. I'm just going to graph that function. So here's what it looks like. That is the function y is equal to x minus 4 times x plus 1. Let's go ahead and find the x-intercepts. You can do this visually, but I'm going to do this actually with my calculator function. So I'm going to calculate the zeros, which we learned how to do in 7.1 and 7.2 if you want to look at those lessons. So it's asking me for a left bound, a right bound, and a guess. So this x-intercept here is negative 1. So that is one of my x-intercepts. So it's negative 1 and 0. And my other x-intercept, I'm going to go ahead and calculate it with my actual calculator. I'll do this 2 times, and for the other ones we're just going to visually guess, because you'll notice some patterns here in just a bit. So that one is 4 and 0. That x-intercept right there is 4 and 0. Next, the y-intercept is here, but the way we can do that is just go and calculate a value. And you can look again in your 7.1 and 7.2 graphing calculator lesson for this if you'd like to. So second, calculate a value, and we're going to calculate the value when x is 0. That gives you a y value of negative 4. So our y-intercept here is 0 and negative 4. And as you can see, this function opens up. All right, let's go ahead and graph the second function here. So this guy right here to the right, which is y is equal to 2 times x minus 2 times x plus 3. So that's this guy here, y2 is equal to 2 times x minus 2 times x plus 3. Go ahead and graph it. And I'm going to have to change my window to go further down. And there we go. All right, so let's go ahead and calculate the x-intercepts. This one will actually calculate. The other remaining ones we won't. We'll just visually approximate and make some guesses. So this x-intercept here looks like it's at the point negative 3, 0. And the other x-intercept, let's go ahead and calculate it. As I'm doing this, you might want to make some guesses as to where you think that x-intercept is. And that's a value of 2 and 0. Next, the y-intercept. We can calculate a value when x is 0. That's negative 12. So your y-intercept is at 0 and negative 12. And this function opens up as well. All right, so let's do the next two a little bit more quickly. So I'm going to do this third one. You'll see on my calculator. It's my y3. So y is equal to negative 0.5 times x plus 5 times x minus 2. Let's go ahead and graph it. And what you'll see from this graph is it looks like, and I'm going to assume that it is, the x-intercepts are at negative 5. So negative 1, 2, 3, 4, 5, and positive 2. So x-intercepts, we're going to say that they are at negative 5, 0, and positive 2, 0. The y-intercept is not quite so clear, so I'm going to actually calculate it. The y-intercept is at 5. And this function opens down. Let's go ahead and do the last one. Now what we noticed here is in this fourth one it says y is equal to negative x times x plus 2. And what you might notice is that that doesn't look like factored form. Factored form tends to look like y is equal to a times x plus r times x plus s. So we like to have a coefficient and two sets of brackets. So what you might want to do in this question is make the coefficient negative 1. And this value x here, you could actually represent it with brackets being x plus 0. Okay, so if you'd like to make it look like standard form, you may want to make it look like this one here. Okay, so a factor of x could also be x plus 0. So there you go. We're going to go ahead and graph it. So here it is, negative x plus 0 times x plus 2. Just 1 second. And we're almost done this lesson. All right, so it looks like our x-intercepts are at negative 2 and 0. So negative 2 and 0. And given that we have an x-intercept at 0, you can assume that if an x-intercept is 0, you also have a y-intercept of 0. So this is also going to be 0. And this function opens down. So we're going to notice some characteristics, and I'm going to let you work on some of these in yourself. But it says, answer the following questions based on the observations from the examples above. So, from factored form without a graphing calculator, how could you determine where the x-intercepts are? Give examples if necessary. So what you might notice, and let me highlight them here for you, you might notice that the x-intercepts are always the opposite of r and s. So, in other words, if r is negative 4, we'll have an x-intercept of positive 4. If r is positive 1, we'll have an x-intercept of negative 1. So, they are the opposites of r and s in factored form. Okay. Second question, and you'll notice that in all cases. Okay. So if r is negative 2, we've got an x-intercept of positive 2. If r is positive 3, we've got an x-intercept of negative 3. That will always be the case. Second is, from factored form, how could you tell the direction of opening? Now let me highlight these things again. These are characteristics that maybe you could notice on your own as well. You can tell the direction of opening from the coefficient a. So let me show this to you in just 1 second here. So, if we have a positive coefficient like 2, or like a coefficient of 1 in this first one here, that helps it open up. Okay, and if you have a coefficient highlighted in green here that's negative, then it opens down. So, a positive a means up, a negative a or coefficient means down. And lastly, I'll do this rather quickly, how can you tell, and it's a little bit more difficult, how can you determine where the y-intercept is from factored form? And what you'll actually notice is that the y-intercept is always when you multiply a, r, and s. So in other words, if you multiply 2 times negative 2 times 3, that will give you negative 12, which is your y-intercept. So it is a times r times s.